Hi everyone, I am Bihan Chakraborty and today I'll be discussing LeetCode's problem number 104, that is maximum depth of binary tree. So I'm sure you have heard of this problem before as well. It's a very common problem and it's an easy problem which is based on trees. Okay, so if you check here, it's tree and depth first search and breadth first search. So it can be solved using both DFS, or for trees you can say level order traversal, or you can do DFS as well. So I'll be discussing the approach for DFS. Okay, depth first search. So how do you solve this problem? So first of all, what's said in the problem is that given a binary tree, okay, so I think it's a binary tree, yeah, it's a binary tree and we have to find its maximum depth or maximum height. So suppose what is the maximum height here? This is height 1, this is depth 1, this is depth 2, and then this layer is depth 3. Okay, so even if there's a single node at depth 4, then the answer would be 4. Okay, so how do you solve this problem? Let's see the solution. So this is the original function that's given to us and this is our recursive function, the DFS function. Okay, so let me rename it as DFS. Okay, so initially we check whether root is null, that is there's no tree, then the answer would be 0. So this is one base case and next we start from 1. Okay, this parameter is the depth. Okay, depth, we have depth and the root. So initially we check whether root is null, then we return 1 here. Okay, first of all we are considering this. So if there is no tree, then this condition won't ever be executed because we are returning from the very first line. But this is for the like empty node. Suppose I'm at 7 and I checked its left and right child, then this condition would be triggered. So we returned 1, but actually it doesn't matter what we return here right now. Let's see the other cases. Okay, so I'm storing the max depth as depth. Okay, so this is my current depth. Max depth is initially my current depth, that is the depth of the root. Okay, now I check whether the root has a left node and a right node. If it has a left node, we recursively move on to its left node and increase its depth by 1, and if it has a right node, we do the same thing for the right side. So let me write it here. Initially I am at 3. Okay, I am at 3. I check whether, okay, 3 and what is the depth? Depth is 1. Okay, now I check whether it has a left child. It has, so I move into 9. Okay, so what is my current node? 9. What is the depth? Now it's 2. Okay, because I'm again recursively in the same function. So now the depth is 2. Now I again check whether 9 has a left child. Okay, so I see there's nothing, so I ignore, this condition becomes false. Next I check whether it has a right child. I see it doesn't have a right child as well. Okay, so what is the max depth of 9? That is its current depth, that is 2. So this function returns 2. This 2 is returned where? To this 3's function, the initial function, the calling function. Okay, here. So max depth here becomes max of 1. This was 1 and this was 2. So max depth becomes 2. Now I go to this side. For this side the same thing happens. I check whether it has a left. It has a left, so we move to the left. Then we check that both of its children are null. So we return its own depth. That was 3. And why it is 3? Because here I was 1. When I'm recursively moving on to the next function, I'm increasing the depth. I'm doing depth plus 1. So for the next functions, every recursively called function will have a depth, its previous depth plus 1. So at 15 I have depth 3, so we return that, and from this side I also have a depth 3, so we return that. So maximum of its own depth and the maximum of depth of left and right child, we take that. So maximum of current left and right is 3, because left and right child have the same depth here and it has its own depth is 2. So max of 2 and 3 is 3. So this node returns 3. Now when it gets to the original function, from the left it had got 2 and from the right it had got 3. So maximum is 3. So we return 3. Okay, so this is the problem. Let me write it again. So for the 3, and I'm writing this as the value of the node. 3's height was 1. For 9, 9's height was 2. Then we check for null. Its left is null, its right is also null, so I'm omitting that. then we go back to 3 again, then we check for the right child. So 20's depth is 2, then we check its left child, that is 15, then we check for the right. So 15's depth is 3, then 7's depth is 3 as well. So these two return 3 to 20. Now max of 2 and 3 is 3, so 20 returns 2 to this 3, and 9 also returns 2 to this 3. Okay, so sorry, 20 returns 3 and 9 returns 2 to the first root node, and maximum of 1, 2 and 3 is 3. So that is our answer here. Let me run this code. Oh, okay, sorry, I forgot to rename this one. Yeah, so it's working, and let me submit it. Yeah, and as you can see, it's a very optimal solution. The time complexity of this solution is O of n. So it's a linear time complexity problem because we are traversing or we are checking each node only once. We are not going to it twice. So that is why it's O of n. And yeah, if you have liked my video, please like and subscribe to my channel. And if you have any query, please comment down below. And yeah, see you in the next video.